Hello everybody, Chris here, and in this video I wanted to talk about my Grid Builder plugin version 4.1 for Godot 4.3 and above, and show you some of the features that are new, and then show you guys how to set up the new version of the plugin for your own project. So if you look at the top-down demo you see on screen, and we look at the controls, you'll see over here at the bottom, I've added a couple new modes, Move mode and Demolish mode, in addition to the original build mode of the plugin. So just like before, you'd be able to select a placeable object and place it into the scene. Nothing new about that. But if I hit 4 to switch to move mode, then we can hover over a object which is marked targetable and movable and be able to move it to a new location. So whether an object can or cannot be manipulated with the current mode, it'll be highlighted by the target highlighter to either be green or red by default, but of course that's customizable. So I'll left click it, and that's going to create a movable copy of the original object and snap to the cursor. So you'll notice based on the rule check indicators under the object that we can place it on the same or similar location to the original object. But if I go over here to where maybe I have one of these staircases or another object that is still active inside of the scene that you cannot place there, just as you would not be able to place there with build mode. But if I go over here and just move it a little bit to the right, then I can left click, place it there, and that'll move the original over to that location. So in order for you to move and then place an object, basically in the same spot but over the original object, there is a setting in the manipulation settings where you can enable that, just so you know. Also to note, while in move mode, you can rotate and flip an object that has been marked to be flippable or rotatable. So the Smithy has all of that enabled, so I can press R to rotate it to the left, T to rotate it to the right, and once again, those are just the current key bindings. F for flip horizontal, and G for flip vertical. So different objects are going to make more sense for what you can and can't do with it, so that is customizable on an object by object basis. To make an object manipulatable, you attach a manipulatable component to the scene, assign the root of the scene, which is the actual base object being manipulated, and then the system will take over in controlling what you can and can't do based on those settings. So if I left click, I can place it back into the scene. I can select this object up here and do similar things. And then demolish mode is 5, so we can select an object which has been marked for demolish and left click to basically delete it from the scene. So when an object is deleted or really any manipulation happens to it, there are signals. And in this case, you'd be looking at the manipulation state resource for those. So if you have your own scripts you want to attach to the system to basically add a little bit more, such as a demolish effect, or being able to look at the object and see maybe how many resources you'd get back, you can do that by connecting to the demolish signal and then respond appropriately. Okay, so let's go take a look at the platformer scene. So in here, I made it so that the boxes in this current version of the test are actually rigid body 2Ds. The reason for that is if you happen to be working with rigid bodies, you might push an object out of its original location. So there's also a manipulation setting where you can take an object once you've selected it, then it will basically reset the transform of the object to identity, which just means no rotation, no scaling, no anything. And then that makes it much easier to place again back into the scene if you want to do something like stack these boxes. So I'm just selecting them with move mode and left click as the confirm for that, and then stacking them on top of each other. Also, if you happen to be using rigid bodies and you move an object to the left like that, that's going to mean that gravity is going to affect those. So if you're doing that type of game, I'm trying to support that as well. And as I mentioned, being able to turn off a layer of the source object while you're moving the target object means that if you put a requirement that the space below it has to have a different layer enabled, such as used space, if you disable that used space layer, then you wouldn't be able to do something like take a box and put it on top of itself, which would be an obviously illegal placement because this is going to move up there. Doesn't make sense. So that was one of the reasons for having that setting. Also, just like before, there's some fun stuff like being able to drag and mass build into the scene. If you want a whole bunch of rhinos doing basically the same thing, you can take this and try to place it down there when the space is free. And I don't know, we set up something like a little zoo down there because why not? Okay, so similar story in the isometric demo. We want to be able to place objects into the scene, but if we're moving an object in move mode, we want to be able to, first off, place it on the same spot, moving an object into itself. But also we could just flip an object with F to flip horizontal, and then place this blacksmith house back into the same spot. So we can just select objects and flip them around and place them again like that. But if we try to place new objects into it, of course, the rules are going to prevent that because of collision checks. But yeah, disabling one layer can be pretty helpful for allowing you to move an object onto itself. Oh, but of course, you can't move it onto other objects because it only disables the layer, the physics layer on that original source object. So let's go ahead and create a new project with the plugin imported. So I'm going to create here in Godot 4.3, and we'll just call it Grid Builder Tutorial. I'll go ahead and put this in the Tutorials Projects folder, select folder, create and edit. So now we're going to want to go to the file system in the bottom left, right-click, create a new folder, Addons. So if you're working on your own project, all add-ons generally go in the add-ons folder. So let's right-click, open in File Manager. Okay, so we have the add-ons folder there. Let's find where we've downloaded Grid Builder 4.1. Double-click to open it up, and then drag Grid Building into here. If we go back to our project now, we should see all the files import. So we have Grid Building down here with all of these folders under it. So we want to enable the plugin, go to Project, Project Settings, Plugins, Enable. And let's create our main gameplay scene where we actually mean to use the plugin systems. So let's go to Other Node. I'll create a new node. I'll rename this to be Gameplay. I'll save it as a scene in the project at the root. And then let's go up to Project, Project Settings, and make that the default scene with Application Run, Main Scene, Gameplay Scene. That way it'll just load into the scene as soon as I hit the play button. So to make setting up the systems as simple as possible, there is a template folder in here where we can open it up, grab systems.tscn, bring that in up here. And then if you do right-click, make local, you'll be able to see all of the systems inside of there. If you expand them, you'll see that all of their resources have been set up by default with a bunch of template resources. So of course, for any of these, you can customize them, make them unique, save them to your project, whatever you need to do. Just note that some of these resources may be shared across multiple objects. And generally, unless you have very specific needs, you want to make sure that all of the systems and other objects that are dependent on them are all sharing the same resources. So you would have one grid targeting state, one manipulation state, etc. And if you just want to use the default resources and edit them, what you could just do is right-click on the resources folder, which contains all of them, and then do move duplicate and just move them to your project. Let's do a building folder, and then we'll just move resources into building/resources. Okay, that way if you happen to upgrade to a new version of the plugin, this set of resources is totally separate from the new version if there are any differences. Okay, so we have all of the systems, and they're not really going to do much until we add a grid positioner stack to actually control the targeting in the 2D game world. So first I'm going to right-click on Gameplay, add a child node, Node 2D. I'll just call this the World node, so rename World. And then I want to go into Templates and look for the grid positioner stack. So if you're using a top-down or side-scroller game, you're going to use the stack.tscn. If you're doing isometric view, you probably want to work from the grid positioner stack isometric. So you can just drag this into the main scene, just like that. If you'd like, you can right-click, make it local, and you can click through it and see the different nodes here. So most of what's here, you're not really going to need to worry about too much. The systems are going to handle that. The grid positioner is going to basically be the point at which you are targeting on your tile map grid. The grid targeter is a sprite that shows where you're pointing at. A manipulation parent, the manipulation system uses that for rotations and that sort of thing. And then the rule check indicator manager will spawn a bunch of indicators for every space that your object is occupying on the grid. So those are the main nodes, but we have to fulfill a few runtime requirements for the systems to actually work. So there are a couple nodes that I've added to the plugin to make it really easy to set those regardless of your game world. So let's right-click on the world and add a child node. And we're going to look for assigner nodes. So we have the grid state assigner. We want to create that. Now, normally I would put this on a game level, but if we just have the world as one big thing, we don't need to continually assign the tile maps on a level-by-level basis. But if you are loading different levels and unloading levels, then you would probably put this under your level scene, not the overall game world. So in here for the state assigner, it's basically going to take these nodes, which we create and assign, and it's going to populate them in the targeting state and building state at runtime so that the systems can run. So let's quick load the targeting state from the default resources. Let's quick load the building state, and then we need a target map. And if we have more than one tile map layer or tile map nodes, we'd want to assign all of those into here, but we also want to include the tile map. So if we just have one tile map layer, we can right click on world, add a child node, tile map layer, which is the new node for tile maps in Godot 4.3. The version 4.1 of the plugin supports both of them. Tile map is now deprecated, but it still is working with the plugin. But because tile map layer needed to be supported going forward, that is why Grid Builder requires version 4.3 of Godot, which hopefully isn't a problem for anyone because it's now in stable release. So most of the bugs or all of the bugs. Okay, so we're going to use tile map layer since that's the main way of handling tile maps in Godot going forward. So let's create that. And then we'll worry about the tile map in a second, but let's go to the grid state assigner. I'm just going to drag the tile map layer into the target map, and I'll also add it to the maps. So one last thing we need here in the grid state assigner is going to be an objects parent. So which node do you want created objects to be put under when they are instanced into the game world? You could just right click on world, have a new node 2D for that as a parent. I'll just hit F2, rename it to be objects, storing all of your scene objects in here under the world, then that makes sense. So let's assign the objects parents to objects. And from there, we just need to kind of create a tile map. So for the tile map, you can do that pretty much however you want. I'm going to just create a new tile set here. Let's go into tile set. We should have the icon SVG for Godot come standard. We can just kind of use that to quickly mock up a tile map. So I'm going to, on the tile set tab here, I'll just drag the icon into here, automatically create tiles. So it's 16 by 16 tiles here by default. So we have a 128 by 128 image. So we get a bunch of tiles here. And I'll just go to tile map at the bottom in order to go to placement. Use the rectangular select tool, R on the keyboard, select all of these tiles. And let's just drag a giant tile map, kind of like that. So we have our background. If we want to make it more obvious that that is a totally separate thing, we could click on the tile map layer node and maybe go to visibility, self-modulate, and change this to something like a dark purple, just kind of make it sort of a background. So that just changes the color of all of the tiles here in the background. So lastly, the plugin requires you to have a user object, which is actually in control of the systems. All of the systems by default are going to use the same user state here. You see the placer state on the building system. The grid targeting system has the origin state. And on the manipulation, you have the manipulator state. So these are all user states. It's just which user do you want to be in control of the system. And you set that on the user state. And the user assigner is the node which allows you to easily do that without any extra code. We can just right click on, let's say, the world, create a character 2D, a character body 2D. It could just as easily be a regular node, though. If you have like a God camera and it's not a 2D object, it'll work just fine. The reason for having the user is so that if you need to access things like an inventory, you can use that user to search it and then find the inventory for things like spending resources for spend resources rules. That's basically the main purpose of the user at the moment. So anyway, we have the character body 2D. I'll just rename this to be player. Right click in it, add a child node. Let's give it a collision shape 2D. Also right click and give it a sprite. And we'll just assign the icon SVG as the sprite there as well. But we can clearly see it's different from the background tiles because of the modulate color. So let's resize this sprite to be 16 by 16. So 128 divided by 8 would be 16. So we want to divide the scale of 1 by 8 to get 0.125. And there our sprite has been scaled down. Now, normally I would just change the image size instead of changing the scale here, but for quick testing purposes, I think it's okay. So we got a collision shape. If we click into here, we got a warning. So we do need to give it a actual shape resource as well. So click here and do a rectangle shape, and then we can expand that, give it a size of 16 by 16. And then now our sprite matches our collision shape. It makes a bit more sense. If you'd like, we can right click on the player and save branch as scene. So in our main root, we can create let's say a characters folder, and then player.tscn is inside of here. The last thing we need on the player is going to be that assign user node. So if we right click on the player in the saved scene and go to add child node, look for assigner, and we do a user assigner, then we need to pick which user state we're becoming the user of. So quick load that shared user state for all three systems. So the player is now the user on the building system, the grid targeting system, and the manipulation system all in one. And then assign the user node to the player, the user root to the player rather, so that we know where to search below for any kind of inventory nodes or whatever else we need to access at any point in time. Also, you probably want to leave set on load checked so that it automatically sets by itself. You don't have to call any code manually that way. Then we can go out to the gameplay scene. Okay, so let's go ahead and hit play and see where we're at. We're probably going to get a lot of errors in the console because it's looking for actions that don't exist in our project yet. So if we look at the building system, we'll have actions here. These are string names that should be set up in the project so that we can actually give commands to the building system. And also the manipulation system is going to have manipulation actions here. This is where most of them are. So basically confirm, rotate right, left, flip horizontal, and flip vertical are actions that we should set up in our project so that we can actually command the system. So let's go up to project settings, input map, and add those actions in. So confirm, rotate right, rotate left, flip horizontal, and those are all underscores, by the way, and then flip vertical. If you don't like those action names, feel free to customize them in the resource, and then you can use a different name up here. So for confirm, I was defaulting that to left mouse button click. For rotate right, whatever you want. It could be T on the keyboard, and then rotate left can be R right next to it. Flip horizontal can be keys below that, like F for horizontal, and then G for vertical. And then that basically sets up your keys. Then we also want to define missions as well. So in building system shared dependencies, we can see those in here. Off mode, build mode, moving mode, demolish mode. So keys that can basically open up the menus as we need. If we go to project settings, and we add those in, off mode, build mode, moving mode, demolish mode. And then in off mode, I might make that escape on the keyboard, build mode, let's say B for build, and moving mode 4 for moving, and 5 for demolish. I'm just kind of using the same key bindings I had in the dev project. So we close those, and hopefully now hitting play, we should get rid of all the other errors. Okay, so yeah, basically all of those were just missing action names. Okay, so one way we could test that it's kind of working is if we open it up and we hit our move mode action, you should see the grid positioner pop up because we're in move mode. If we hit escape, it should disappear because that goes to off mode. 5 goes to demolish mode, and B goes to build mode. So basically we have those set up, and we can at least toggle the modes on. But we actually have nothing to build. We have no UI added to allow us to pick what we're actually going to build and move around. So if we look in the UI folder, there is a placement selection template you can use as well. So the placement selection UI, we're going to want to put that on basically a HUD layer. So I'm going to right click on gameplay, add a canvas layer node. So this will separate any camera movement from the UI, so the UI can just stick on top of the screen and it shouldn't move out of its place. And then we could put in placeable selection UI into here. So this template here for the selection UI is really just a sample. You can create any UI you want as long as it responds to the signal on the mode state when it switches over to build mode and pops up your menu for selecting what you want to place into the scene and have it work with the placeable resource. You can really customize it however you'd like. But for a simple setup, let's go ahead and assign the build system here. So assigning the build system directly. And then you can also see the mode state is defaulted here to the template mode state. So that's how it's going to respond when this gets switched to build. And then we have settings here for customizing what categories we want this menu to have to show in different tabs, and then which placeable objects we want to be able to place into the scene. So for the most part, pretty straightforward. So let's create some categorical tags. I'll open this up and create one. Let's do a new categorical tag resource. I'll expand this and say building. For the icon, I'll just quick load, let's say the wrench icon, which I'm using for other things in the project, but it can just be there for that. Why not? You might want to give it a resource name. So instead of just a categorical tag, we could say building category. And then let's save this to the project in building resources. And then I'll create another folder here for categories. And then we have tag building.tres, save it. So now that we have this building category, if we assign it to a placeable, that placeable should show up on the menu as a building option. Of course, with this current version, you still have to assign all of the placeables you want to show up here and to this array. But aside from that, yeah, it should work like that. Okay, so let's work on a new placeable. So there'll be two components of that. There's the placeable resource, and then there's the game scene you're actually trying to instance into the project. So let's work on the game scene first. I'll add a new scene at the top, a 2D scene. So the root here can be whatever you want, but I'm going to make it a static body 2D by right-click and then change into static body 2D. So a static body 2D is a collision object, which means when you're checking the rules against the tile map, you can see if there would be some kind of collision for this object against the other objects on the tile map or above the tile map, basically in the game world. So if we rename this to be, I'll just say Godot building, why not? And I'll right-click, add a child. Let's give it a sprite 2D. I'll quick load a texture. So let's see, I'll just grab the icon SVG. Now I'm kind of overusing that here a little bit, but hey. And in the transform, I'll make this 50% size with a scale of, and then in the scale down here for the sprite 2D specifically, I'll change the scale to 0.5 so that it's a quarter of the size of the original image. So for saving this scene, I'll go to the root of the project and I'll create a folder called objects for the actual objects that are going to be placed into the game. Let's save it as Godot building.tscn for now. And you'll see that for the collision to work, it does need to have a collision shape. So I'm going to right click here, add a child node, collision shape 2D, add a shape to it, and let's make it a rectangle shape with 64 by 64 pixels to match the sprite. Okay, and that should be okay for a scene we can instance. So we need to create a placeable resource now. In our project, I'll go into objects and right click, create new folder, placeables, or maybe just, yeah, let's call it placeables. And then I'll right click in here, create a new resource, placeable. And this is going to be placeable Godot building. So really important for every placeable, we want to make sure it has a packed scene to actually instance, if nothing else. So let's quick load here, or you can drag and drop the object/Godot building we just created. Okay, so now as a packed scene, warning shouldn't pop up anymore. And we can go to the display name. I'll call it Godot building. The icon, of course, will just be the icon SVG. The tags, we'll add one and quick load our tag building. And then the placement rules, for now, we will leave that as the default. We're not going to ignore the base rules on the placement validator. We'll go to that in a second. And we can go to the gameplay scene, placeable selection UI, and assign the placeable. So we only have one, so I'm going to quick load it. And then let's see if we can get the menu to pop up with that placeable object. So play, we hit B, and we have a Godot building. So I'm going to select it, and you'll see that it is now there for placement, and we can left click to place it into the scene. Oh, you also notice certain issues, such as we can place it over an existing Godot building, and that's because we haven't assigned any rules yet. But it is snapping basically to the area on the tile map. We can't go outside the tile map, so it does have to be a valid area in order to be targeted. But yeah, pretty much working there. So let's add a couple more things at this point. First off, I'm gonna right click and add a camera 2D. Let's have the camera zoom a bit. So I'll give it a scale of 2, and it'll be over the 0, point, which is where our tile map is. So when we hit play, it should already be focused more on the center of our area rather than somewhere else. Now, for making the building system actually have rules. Let's go to the building system, click on placement validator. So with the placement validator, I might change the name here. Let's say custom validator, since now we're going to add rules to it. And in base rules, I'm going to add one here. I'm going to select collision check rule here. So for a collision check rule, by default, it's going to fail if there is a collision. So basically, for the objects that have this physics layer or these physics layers, what do you want to check for against the tile map and other objects in the scene? So if we have layer 1 mask, so objects on layer 1 are going to check against spaces on the grid that are having objects that also have physics layer 1. And if there is a collision on physics layer 1, the rule is going to fail and it won't allow you to place. So we could actually leave that as the default for right now. To make it much more clear what is happening behind the scenes, there's another node we can add in. So the build log is going to be very helpful for us. So there's a default scene for that as well, build log.tscn. We can drag that into the canvas layer and zoom out a bit. You'll see it's defaulted to the bottom left-hand corner. And there's a lot of settings here we can customize. So for validation results, if you want to see all of the information, you can toggle every single one of these on, but it's a little overkill. But by default, this is connected to the template building state and the template manipulation state. So if we hit play, it should basically work out of the box. So let's select our building, place it into the scene, and then you see built Godot building. And if we place another one, then it'll use the node name to show what was being built by default. You also see if we try to build the Godot building over our existing objects now, and we left click, it'll say you must have no collisions because these are on layer 1, and we're trying to place an object onto layer 1. So the rule check indicators, which are all those green squares you see behind the object, those get generated based on the apply to layer mask from the rule. So any collision object that is on layer 1, it's going to generate the indicators for. And then it's going to use those indicators to check against objects behind it on the grid or just occupying the space, really. They don't necessarily have to be on the grid. It's just in that space of the game world. And if a collision is detected, you can see they changed to red because the rule is now failing. But when I left click, it'll actually show up in the game log that we tried to execute the rule, that we tried to execute the placement and it failed because of those reasons down there below. And these messages are pretty customizable if you go through the rules and you look for the messages resources. So you can kind of have it say whatever you want. Also, if we go right around here to where the Godot object is in the center, we can see that we can also not place there. So our player is blocking our placement too because it is also on layer 1. Now, you will see that although that is a one tile character, that because it's not snapped to the grid right now, it's actually blocking 4 spaces of tile indicators. So by default, everything will be placed onto the grid when you use the building system, but you may also want to make sure that the objects that are regularly in your game world are on the grid if that's important. Or if they're freely moving around, then that might not be an issue at all. But just something to take note of, that the position does matter in determining which squares will or won't work. Okay, so if we place an object into the scene and we hit 4 to go to move mode, you'll see that we can't actually select another object and move it around. Also, you might notice that there's no target highlighting and the cursor doesn't change. So those are 2 separate nodes we can add in as well. So really, we're getting to the 4.1 part of the tutorial here. So also you'll notice that when we're in move mode, that the targets aren't being highlighted for whether they can or can't be moved around. We also can't select them by left-clicking. So first off, if we want an object to be targetable, then you need to make sure that the grid positioner has the same layer as the objects you want to target. So in the dev project, I was using layer 11 for that. So if you don't want everything in the world to be targetable, which highly advisable you don't, then you should change this to a different collision mask like that, and then go to each of your objects and just put them on, let's say, layer 10 as well. So you can click here, edit names, and say layer 10 is targetable, so that you remember that anything that can be targeted by the grid targeting system should be on that layer. Okay, and then if you just keep the tile map off of layer 10, then you shouldn't be accidentally targeting the tile map. Okay, so we also want to add a target highlighter to the manipulation system. So look for a target highlighter. Then we're gonna quick load the states we need. So because we only have one in our project, it's really easy to understand. We just quick load all of them and we share them between things. I think the highlight settings is the one that is different though. So this is specific to the target highlighter. We can expand this. And this is basically just a set of colors, how you want everything to appear when it's being targeted in the various states. So if we hit play now, and we place an object, and then we hover over it with move mode, then you'll see this one turns red. So it can't be moved. Why is that? Well, it's because it has no manipulatable node attached. So if we go to the Godot building node and we right click add a manipulatable node, then we want to create a new settings here for this node. You may end up sharing the settings across many different nodes if they more or less all work the same. And here you can define if it can be moved, demolished, rotatable, flipped, or flip vertical. And we want to assign the root to the Godot building root static body node. So whatever the root of your object is, that should be the root here. Okay, so let's just enable rotate, flip, and flip vertical as well. Go to play mode, go find our object after we place it. So place a new object. Still can't place here. Have to place it where there is no collisions. And then we can hit 4 to go to move mode, left click to select it. And you'll see that we can't place it on top of itself because we haven't enabled the setting for that yet. But we can rotate with R and T. We can left click to place it. And then we can also hit F and G, I believe, to flip vertically or horizontally. And then when we're done, we just place it with left click. Now, if you want to be able to place onto itself, which in a lot of cases, I think you would, so that you could just move something slightly, then we want to go to gameplay, go to the manipulation system, settings, toggle on disable layer and manipulation, and then let's pick a layer for that. So I might say layer 12, and then if we go to the Godot building object, we'll put this in layer 12. Let's edit the layer names, and then let's call it used space. So as in space which is being occupied by this object. And you might have different child nodes which aren't on the world physics layer, the default layer 1, for blocking objects, but they might be taking up space for buildings. So you can use used space layer for that. But your main layer for physics collision, regular physics collision, is a totally separate thing. So I'll just call this world for layer 1. Okay, so then if an object is using space, then you can't place onto it. And we'll have to set up the collision rule to do that. So we also want to add the same thing to player. So if we go to player on the collision tab, collision object 2D down here, let's put this on used space as well. So the player occupies space in the game world, so it makes sense to have it on used space. Now, if we go to gameplay and we go to somewhere where we have the placement validator, we can change the rule to, instead of checking on world, we'll check on used space. For now, we can still have it applied to objects mask 1, just whichever collision objects 2D from the scene you want to pick up and have that applied to the rules. That's what you're dealing with here. So let's hit play and see if that works. So I will grab this, place it into the scene, and then I'll pick it up with 4 to go to move mode, pick it up, and you'll see that the manipulation system disabled that physics layer for the object behind it. So now we can move it, we can place it, and we can just like rotate it, keep it in the same spot, flip it, same spot. And that's basically how you can move an object right on top of itself. So that's the majority of the basic setup there. Of course, there are more placement rules. I have past tutorials on those kind of things, especially setting up like spend materials rule generic. Likely, I'll have a follow-up video or multiple follow-up videos to this one, just going over those fine detail points of the system. But hopefully at this point, it's pretty clear how the system comes together and works, and the requirements you need from your game world in order to have placeable objects be placed into the game world, and checking the requirements with rules like the collision check rule. So you can find my plugin on Ko-Fi, Patreon, and itch.io for download. So thanks for watching my video to the end. If you liked it, feel free to hit the like button, comment, and subscribe. And I will see you guys in my future video content.